Hello everyone. In this video, we will be talking about the third question in the weekly contest 397, which was maximum difference score in a grid. Let's go through the question. If you are given an m cross n matrix grid consisting of positive integers, you can move from a cell in the matrix to any other cell that is either to the bottom or to the right, not necessarily adjacent. The score of a move from a cell with the value C1 to a cell with the value C2 is C2 minus C1. Uh, Here there is no modular sign. That is, they are not taking the absolute value for this. Basically, if I go from 7 to let's say 14, so the value will be for this move will be 14 minus 7, which is 7. But if I try to go from 9 to 3, then the value will be 3 minus 9, which is minus 6. So this is a very important point to notice. It has been also mentioned that you can start at any cell and you have to make at least one move. So whatever we have been given, the input array, we have to make at least one move, let's say from anywhere to anywhere. That is why in the constant we have been given the minimum value of the size of the grid as 2. Because other than that, we will not be able to make any other moves if the size of the array would have been 1 or the grid would have been 1. What we need to do is we need to return the maximum total score that we can achieve. Let's talk about the first sample case. Here, if we want to go from 9 to anywhere in the grid, let's say to 3, then the move will be having a score of minus 6. And let's say from 3, if you want to go anywhere to the bottom or to the right, we can go. So let's say we're going to 1. That will be having a score of minus 2, which will be giving me a score of minus 8, right? But if I want to go from 5 to 7, right? So that will be giving me a score of 2 plus. If I want to go from 7 to 14, that will be giving me a score of 7, because what is happening here is 7 minus 5, which is 2, plus this 7 is coming from 14 minus 7, which is 7. This will be giving me a result of 9. And with any other way or any other path, I will be getting a value which will be lesser than this number. Let's say we are going from, let's say we choose the value, this 7, right? And we try to go from 7 to 14, which will be 7, and from 14 to 3, which will be minus 11, right? Because 3 minus 14. So this will be minus 4. Similarly, if you try to go from anywhere to anywhere in this grid, following the rules that we can go to only bottom and right, we will be getting values less than 9. So 9 is the maximum value that we can achieve. Here there is a very crucial observation that we can make from this line, right? How and what it is. So let's say we are going from A to B. A can be anywhere in the grid. In the top or the upper left corner, let's say here A is there and here B is there. If I want to take this route, or if I want to take this route, or if I want to take this route, whichever route I may take, let's say this is C, this is D, this is E, this is F. Let's say with whatever route I want to take, A to C and then to B. Here the values will be C minus A plus B minus C. This is R1. Let's talk about R2, which is ADEB. So this will be D minus A plus E minus D plus B minus E. What we can see here is this intermediate values will get cancelled. C, C, so D and E. So D and D, E and E. What we are getting at the end is B minus A. Here also B minus A. We can check for the route C as well. This AFB. This will be B minus A as well. So what I mean to say here is from wherever I want to go, that is in my top left corner, to a point which is at my bottom right corner, the jumps value or the moves value will be B minus A. Or let's say it was X and this was Y. So X minus Y. This is a very crucial observation which can solve the problem in a very easy manner. Now here after this observation, what I want to do is for any input, if I have two values, let's say this is uh, A and B, A1, B1, A2, B2, A3, B3, where A is the value that is present in my grid for the value for the indexes I and J, and B is the minimum value whatever is present in the top left corner of this, you know, of this cell. Let's say I'm talking about this cell. So there might be a minimum value which will be present here, and there might be a minimum value which will be present at here. Similarly here. But I'm not considering this value currently. So whatever will be the minimum value present in this region, right? I can consider this value as my, initial point and this value as my end point. And I can go from that minimum value point to here, which will be B minus A. If A, right, sorry, A minus B, as A is the value of this grid's cell, and B is the value of minimum whatever is present in this region. So the value will be A minus B. How can we calculate this minimum value? I can calculate the minimum value which will already be present here, and I can calculate the minimum value which will already be present here. And but here the minimum value will not be considered using this A. What I mean to say here is, let's see how can we consider the minimum values of a region. Let's say this is AI and BI. So AI is nothing but the grid's value, but BI is the minimum value of this region, which I'm marking right now, right? How can I get this minimum value? Because this value does not consider A in its calculation. Similarly, it will be for the every cell. In this cell, A will be A of I minus 1 and B will be B of I minus 1. Here, for the calculation of B of I minus 1, A of minus 1 will not be considered. And B of I minus 1 will be the minimum value present in this region, right? Let's say this is A of J minus 1 and B of J minus 1, where I and J are the X and Y coordinates. Now, in the calculation of minimum value for this cell, A of J minus Y will not be considered, but the region this which I'm currently marking will be considered. So while considering the minimum value of Bi, what I will be doing is I will be taking the minimum value of these two, right? And the minimum value of these two. Let's say minimum value of A of I minus 1 and B of I minus 1 is X. And the minimum value of A of J minus 1 and B of J minus 1 is Y. To calculate the value of Bi, what I will be doing is minimum value of X and Y. This will give me the minimum value of this region, this whole region. And I can do this for every cell. After doing this, if I traverse through the whole vector, 2D vector, I can get my answer if I take an integer answer as int min, and answer will be maximum of answer, and this a minus b, ai minus bi, where bi I have already considered. In this way, I can calculate whatever will be my, you know, maximum answer for this particular input. Let's see how we can do this using our code. So initially what I've done is I've taken the length and breadth of the input grid. I've taken another matrix where I'm keeping the pair that we have already discussed of the same size, and I'm keeping int max here for the second value. For the first value, I'm copying all the values that are present in my grid to the mat's first value. Now for the second value, what I'm doing is I'm using this for loop. For the value of 0, comma 0, I cannot, take consider this as my endpoint because there will not be any starting point before that, right? That is why whenever the I is 0 and j is 0, I'm continuing it. For all the other cells, what I'm doing is I am taking the minimum of the pair, whatever is there. If I minus 1 index is valid, I will be taking the minimum of ai comma bi. Basically, I will be taking the minimum of these two, which is represented as mat of I minus 1 j dot first and mat of I minus 1 j dot second. Similarly, if the index j minus 1 is valid, I will be doing the same, right? And at the end, I will be taking the minimum value of which is mn to the mat of I comma j dot second. And at the end, I will be traversing the whole matrix, right? Not for 0 comma 0, but for all the values. And I will be checking what is my maximum answer. Basically, this is A and this is B, A minus B. And at the end, I'll be returning my answer. Let's try to run the sample test cases. is getting accepted as well as all the other test cases. Yeah. Let's talk about the time complexity for the same. I'm traversing through my whole mat array first to, initialize the first value to grid off whatever the cell's value is. So this will be taking, you know, n into m. And I'm taking n into m to find the minimum value, which will be my second value. Again, I'm traversing through the whole mat 2D array, which will be n into m again. So the final time complexity is 3 into n into m, which is n into m. And my space complexity is I am taking this mat 2D array extra, which takes n into m as a space. Hence, my time complexity is n into m, and my space complexity is n into m, which lies within the range. Hence, my answer is getting accepted. Thank you.